Hello everybody and welcome to this special presentation of PESA Presents for a very special little guy, Subatomic Particles. This presentation and all subsequent shenanigans are dedicated to a lovely family I met at my local Walmart recently that, without going into the specifics, they were concerned about their son grasping certain events in school. So this is hereby dedicated to him, and I'm sure, buddy, you'll do just fine this year. You're brilliant. Don't worry, you got this, mate. So, in his honor, here we go. Now, all things in this world, be it the sky, a necktie, or chicken pot pie, matter is made of atoms. Now, an atom is the smallest unit of matter. Matter, just think of things. An atom is the smallest unit of anything, really. It is the tiniest bit of a thing that cannot be broken down into more different things, like how, say, if you had a cheese sandwich. Now, if you had a cheese sandwich, you could pretty much take it apart into the cheese and bread. Well, sort of. Now, that, again, is not an atom. Atoms are very, very, very small. Just one atom is about 1,000,000 times smaller than a human hair. So if atoms make up matter, then, well, what makes up an atom? Now, the answer to that is subatomic particles. There are actually several kinds of subatomic particles, but just to keep this simple on the basic ones, as the family requested, we will go into the key ones. Now, there are three basic kinds of subatomic particles, each of which is basically, think of a building block for an atom, kind of like a Lego, except they don't hurt like death when you step on them. Now, they are different in terms of their charge and their relative mass. Now, this right here, overall, here is your atom. Now, in the middle, in the nucleus, you have protons and neutrons. Protons have a positive charge. Neutrons have no charge. And again, they're together in the nucleus. Now, both neutrons and protons have a relative mass of 1 AMU. That is a unit of measurement that stands for 1 atomic mass unit. Now, outside, you have the electrons, out in what is called the electron cloud. Now, you can kind of see that they look a little bit smaller in the picture. Yes, that's just a picture, so obviously it's not like a real photo of an atom, but still, electrons are a lot smaller than protons or neutrons. So, how small are they, you may ask? Well, they're 1 over 1,840 AMUs. They're a lot smaller than either a proton or a neutron. See how with all of these examples, so from left to right, you have hydrogen, carbon, oxygen, and nitrogen atoms. It's the little guy, I guess, he was most interested in carbon atoms because of carbon dating with fossils, because he liked dinosaurs. So here we go. So this right here, buddy, is a carbon atom. So see, this has 6 protons and 6 neutrons. And then over here to the right, the oxygen atom has 8 protons. But then on the left, the hydrogen atom has only 1 proton. So you see how all that's different? Well, there's a reason for that. The atomic number is the number of protons. The number of protons basically defines an element and what it can do. Now, an atom at its lowest energy level has an equal number of electrons and protons. I just did this one then for something different. Now, an atom's charge is determined by its subatomic particles, its electrons, its protons, its neutrons, and also the charge of a chemical compound. Now, an atom's mass is the total of its neutrons and protons, which again are in the center called the nucleus, as electrons, which again are on the outside, called the electron cloud. As electrons are so small, they are not included in the mass. So for some additional resources, I found these at our local library. It's a nice little 3-part book series for kids. My first science textbook series, no official endorsement, just something that I thought would be nice. Protons, Neutrons, Electrons, or Atoms by Wissinger, Koviu, and Rhodis. So I hope that this helps, little buddy, and if anybody has any questions, please feel free to ask. Thank you very much, folks, and have a lovely week now. Bye.